Okay, let's talk unit circle. This is where we start talking about trigonometry and trigonomic functions. We start talking about radians, and this is really just your beginning of trigonometry. So in a previous video, I showed you how 30, 60, 90 triangles and 45, 90 triangles work and their functions. And so go back to that video if you haven't seen that. You also learned that in geometry. So here in trigonometry, or some of you do this in the end of algebra 2, I try to remind you of a few things. Sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent is opposite over adjacent, and you can also think of tangent as sine over cosine as well, okay? So I'm going to break it down, and I'm going to take this into two videos. The first video, we're going to fill in this chart right here about what all the ratios are for the different degrees for our special triangles. After that, I'm going to make another one where we talk about sines and reference angles and how you find something if you get, negative 210 degrees. How do you figure that out? We'll go over all that. The biggest thing is that 30, 60, 90, 0, and 45, and we're just going to memorize them. If you get that, you are in perfect shape to move forward, okay? So let's start with the unit circle. It's called a unit circle because the radius is 1 going all the way. So if I were to just take any angle, and I'm going to go right here, and I'm going to call that a 30-degree angle, so that means that this right here, if I were to make a right angle, there's my 90, and there's my 60, okay? So there's a 30, 60, 90 triangle, and I know that that right there is going to be 1, because that's the radius. So now I look at everything else. Now, I taught you, I'm just going to write it over here real quick. And why don't I just write it in the way that it looks here so that part's not very confusing. Sorry about that. Boom, boom, boom. And what we learned, if you watched my previous video on this, okay, is that if this side is 1, or x, okay, the hypotenuse is going to be double. And this side is going to be whatever x is, which is 1 times square root of 3. Okay, or just square root of 3. And so that's something that you learn. But if you look right here, the hypotenuse is 1, not 2. So if I were to use this ratio, this would be 1/2, and this would be 1/2 times square root of 3, or square root of 3 over 2. Basically, all we did is I took all 3 of these and I cut it in half. And the reason I did that is because, well, I want it to look like that. But ultimately, I can take any single triangle, these are just ratios, and to get rid of this, I multiply by 2, and I end up getting this ratio right over here, and that's the y, okay? If any of that was confusing, don't worry about it. I just want you to see that this is the ratio of a 30, 60, 90 degree triangle, okay? So, let's take a look at it right now. I'm going to do the sine of 30. Well, the sine is opposite over hypotenuse. The opposite is 1, the hypotenuse is 2, so the sine is 1/2, okay? Let's go ahead and do the cosine of 30. The cosine of 30 would be adjacent, which is square root of 3 over 2. So root 3 over 2. And the tangent of 30 degrees would be opposite over adjacent, so that's 1 over root 3. And we can write that down, but we usually don't like to see that square root in the bottom. So to fix that, I'm going to multiply the top and the bottom by root 3, and so that becomes a root 3 over square root of 3 times square root of 3 is normal, everyday 3, and so we get a root 3 over 3. Let me move back here so you can see that better, okay? So now, in your textbook, you probably now see a 60, where we do a 60 and a 30. But watch, we can do that right off of here, okay? And then we don't have to write a whole other triangle and make it way more confusing. So let's do 60. 60, what's the, if we go sine of 60, opposite is root 3 over the hypotenuse, which is 2. So we get a square root of 3 over 2. Now, let's go ahead and do the cosine. Cosine of 60 is adjacent, which is 1, over hypotenuse, which is 2. Now, I want you to notice this. Notice the sine and cosine for 30 and 60, they just flip-flop, okay? So if you just memorize the sine, all you have to know is that 60 flip-flops it, okay? Sine of 30 is 1/2, well, the cosine of 60 is 1/2. cosine of 30 is square root of 302. Well, that's the sine of 60. So they just flip-flop. So take a look at this relationship. It'll help you to memorize them, okay? Now, if you go tangent, well, tangent of 60 is going to be opposite square root of 3 over the hypotenuse, opposite over adjacent, which is 1. So that's just going to be a normal, everyday root 3. Okay? Cool. So now we have to worry about tangents now. So I do have to draw another triangle. Now I don't want it to get too confusing, so I'll do a really poor job killing this one. Actually, you know what? Let's take a break while I go ahead and erase the board. Okay, so let's go ahead and do our tangents right now. If you go and you remember what we did with our tangents, if I have one right here, the legs of this are always going to be whatever the hypotenuse is divided by square root of 2. Again, that was in our previous video. So this is 1 over root 2, and this leg also is going to be 1 over root 2. Now, if we want to rationalize that, what we're going to get is, I'll do it over here, 1 over root 2. We're going to times everything by root 2. So it looks like that, and that's going to equal root 2 over normal everyday root 2. So why don't I just change that to that, root 2 over 2, and this right here is going to be root 2 over 2. Okay, so let's take a 45, and if you notice it's 45, 45, it's all going to be the same. So if I'm going to go now, sine of 45 is going to be root 2 over 2 over 1, or just root 2 over 2. Okay, so that's going to be this root 2 over 2. If I do the cosine, we'll take a look. Instead of that, it's going to be that. Root 2 over 2 over 1. Now I'm doing the adjacent. So look, it's the same thing. Root 2 over 2. Now what I like is if you remember this, that tan is going to be sine over cosine. Well, we're just going to go sine over cosine, which is going to be the same thing over the same thing. And whenever that happens, all you do is you get a 1. Okay? Now, go with me on this little thought experiment right here. We're going to draw a triangle with an angle of 0, which of course you can't do, that's a straight line. But let's just pretend like we can visualize this. So here's what I'm going to do. I'm going to do a triangle, and that's going to be an angle of 0. And so that means that this side, what it really is this hypotenuse is touching that line. So we're just looking at like a straight line right here, which I didn't draw straightly, but that's okay. So this would have 0, and this would have a length of 0 because it's not going up. I'm just writing it as a triangle so you can visualize it, but you normally wouldn't have a triangle with side 0. So if 0, 90, this would also be 90 degrees right here, if you're to think about this, okay? Just go with me on this, trust me. Okay, so now let's go sine of 0. Well, sine of 0 would be opposite over the hypotenuse. Well, what's the hypotenuse? Well, it would go all the way out on the unit circle, so that's going to be a 1 right there. How about this length? That's also going to be a 1 right there, because remember, these are touching, they're the same line, and we have a height right here of 0. So that's what our triangle looks like, and that's how we're going to do all these functions. So sine of 0 is going to be opposite over hypotenuse, which is 0. Okay? Cosine of 0 is going to be, again, adjacent, which is 1, over the hypotenuse, which is 1. So your cosine is going to be 1. And your tangent of 0 is going to be opposite over adjacent, which is 0. So let's plug in our chart, okay? Sine of 0 is 0. Cosine of 0 is 1. Tangent of 0 is 0, okay? Now, let's do it off of 90, okay? So let's go sine of 90. That's going to equal opposite over hypotenuse. So that's going to be a 1. Whoop. Cosine of 90, sorry, I don't write as well as we get down. Cosine of 90, where it's going to be adjacent, which is 0, over the hypotenuse, which is 1. So that's going to be a 0. Now look what happens to tangent of 90. Tangent of 90 is going to be opposite over adjacent. We can't do that. We can't have 0 on the bottom, so it's undefined, no solution, Done. Now, I want you to notice a few things. Just like the sine and the cosine for 30 and 60 are opposite each other, notice that the 45, they're the same, your sine and your cosine, but also look at your 0 and 90, they're opposite. So if you know all your sines, you can just know the relationships and find all of your cosines. You're going to have to remember the tangents, so those are a little bit different. But what I want to encourage you is to take this chart and just commit it to memory. Flashcard, treat it like a multiplication table. If you have this in your head, you are going to love life. So memorize the chart. I've got nothing great to tell you. This whole video is about showing you how to get to the chart. It's great if you know it, but ultimately all you got to do is memorize this chart. So I'll put one online for you to download and just study the heck out of it and memorize that chart, and you are going to love life. Now, how do we use it? How do we find it? That's the next video. I'll see you in part 2.